I just want to talk about, like, if you're faced with a problem, a programming problem, like, how do you go about solving it? And then also, I just want to teach you a bunch of Scratch stuff that I haven't taught you yet, because this will be the last Scratch lecture. Ooh, we're going to switch to Python after this, so that's exciting. So let's get started. All right, so let's talk about just, like, somebody gives you, or I give you, your boss gives you a program to write, like, you've got a problem in front of you. How do you go from, like, the description of the problem to the answer? Because that's what you need to get good at, right? I can't just give you hints all day long. That won't happen in the real world. How do we do it? What happens when you're trying to write a program? What is the process? All right, so here's, like, a general process that we can kind of understand together. So our goal is to perform some task, to write a program to do something, right? Something needs to get done. So we need to understand three things, I would say. The three main things about the problem. We better understand the problem itself, right? Like, what's going on, like, read the description of it, like, what is needed of us, so that we can kind of extract, like, what are the little concepts involved? Am I going to have to add, multiply, make a window over here and a display an image over here? Like, what are all the concepts? Try to pick them apart. Concepts involves stuff like that. And then usually, pretty much every time you write a program, right, you're getting stuff from the user. The user's interacting with you. They're clicking your buttons. They're giving you numbers, whatever you want. There's input. There's always input. Otherwise, the program's not very fun, right? It doesn't do something different. So you need to figure out what are you getting from the user. Like, are they going to click things? Are they going to give you a number? Like, what will the user give you? That's a key piece of the problem, right? What will the user give you of your program? And then your job is to take the user's inputs, right, their clicks, their numbers, or whatever, and produce some sort of output, right? That's, in general, that's the game, right? So, like, your output is the answer you're giving back. What is the answer that your program needs to compute? And I'll put answer in quotes, because sometimes the answer is not a number, it's just like an experience. Like, the answer is a video game if you're working for a video game company. I don't know. What is the answer that your program gives back? Do you see how it's very important to understand all these things? Gives back? Question mark. Okay. So, yeah, in general, the user's giving you inputs. They're giving you numbers, clicking stuff on their keyboard. Your goal is to make a strategy that takes the inputs and maps them into the outputs. I hope that makes sense. Like, they gave you these things. Use them to produce the right answer based on those things, right? So take the inputs to the outputs. I'll draw another arrow, a second arrow. It's so important, right? Because that's, at the end of the day, that's what every program's doing. You're giving your program input. Like, I'm clicking here in PowerPoint and it does something. That's all a program is at the end of the day, isn't it? Just like taking inputs to outputs. And we got words for that, right? An algorithm is a sequence of steps to solve a problem based on some ingredients, right? It's like a recipe. So, in general, that's what you got to do to make a program. Does that make sense? Are there any questions about that? We never thought about it at that high of a level, but that's really what's going on. It's just like inputs to outputs. That's all we're doing. After we understand the problem, of course. That's important too. Okay, so yeah, I just want to show you a few examples of that. We'll break down some problems together in this kind of way. All right, so I'm going to go to Scratch if you'd like to follow along. Scratch.mit.edu. Ooh, it worked the first time today. Nice. So here's my nice blank program. Here's my first example. Let's calculate the factorial of a number, n factorial, where n is something that the user gives us. So we all know the factorial from math class, right? It's the exclamation point. It's like if someone gave, if you're trying to solve for 5 factorial, that's just all the numbers multiplied together up to 5, right? So 5 times 4 times 3 times 2 times 1, so 5 factorial. Let's say we're going to make a factorial finding program, okay? So let's think about this. So what's the input? What's the output? What is the problem itself? Like, what do we need? We're going to need to multiply, right? Stuff like that. Let's write it all down. Let's list it, because this is what you'll be doing in your mind. It's maybe what you've been doing already, just like not in a cookie cutter way. Now we can break it down like this. So we're getting one thing from the user, right? They're giving us the number that they want the factorial of. Yeah, that's the one input. That makes sense. And then we're spitting back out, after we compute the answer, that factorial, right? We're giving them back another number that we're using their original number to build. Yes? So that's important. And then, yeah, the problem itself is like we got a number. We need to find the factorial of that number somehow. Okay, so like 5 factorial is this. Like how do we compute that is now the question. Okay, so like that's your main problem. Like actually computing the factorial. We'll talk about how to do that in a second. But as you're thinking about like, okay, what do I need to do? What's going to be involved? You should also be thinking about like how could it go wrong? Like what are all the weird things that the user could do? Because they're just giving me numbers, right? Is there always a factorial for numbers? Is there a factorial of 2.5? The user could type that, but that's no such thing, right? So that's interesting. So like the factorial of numbers with decimals does not exist. Also, the factorial of negative numbers is undefined. So you have these little sub-problems that you're noticing, like, okay, thinking about what could the user give me? What am I supposed to do? You're discovering that, okay, there could be errors, couldn't there be? Okay, your program maybe should handle this. It's like the factorial of negative numbers does not exist. And then you need to decide like what you do in that case, because it's always you're still producing an output. You can't just like have the program blow up. What do you do? So maybe you'll just like output an error message rather than trying to multiply things. It's up to you. It depends on the use case, but like that's a thing, right? You got to think about little mini smaller problems, sub problems inside of the main problem. But like if the user gave you something normal, you still have to do the right thing, right? So the main problem is still computing the factorial, and here is an algorithm to do that. So let's say the user gave us a good number. We want to calculate the factorial of it, and we called it n, right? N is the user input. We want to calculate n factorial. So we got n from the user. Let's say that they did give us 5. They wanted 5 factorial. What do we do? Like that's a variable. How do we mess with that? Okay, so here's an algorithm that I came up with that you maybe will come up with one day yourself. So I'm going to have 2 variables. I'm going to keep track of, well, I'm going to need this n variable for sure. That's the number that the user gave me. Otherwise, I don't know what they wanted the factorial of. I need that for sure. And then I'm going to use another variable called out. It'll be short for output, right? And what I'm going to do with this out variable is I'm going to put all the multiplying numbers into out. And so I'm just going to keep multiplying numbers 5, 4, 3, 2, 1 based on n into out. And so that means out should start at 1. So I'm going to multiply stuff into it, have it like work out. So I can't start out at 0, right? Because if I multiply numbers into 0, it would just stay 0, wouldn't it? So when you're multiplying, it's got to be starting at 1. And then we'll just keep multiplying the current value of n into out and making n smaller, because watch what will happen if I do that. It's like, all right, multiply the 5 into out. Now it's 5. And make n 4. See how that's now, if I just kept decrementing that number, the n variable, I'll have the next number I want to multiply by. See that? That's pretty nice. And then now, okay, take the 4. Take whatever's in n now, multiply it into out. And so that'll make it, what, 20, right? Do you see how that will just keep building up the right answer? So like that's a process that we can loop, because it's just like take whatever's in n, multiply it into out, decrement n. That's my next number. Now I got the 3. See how that's going to work? 3, multiply it into out, that'll be 60. Make it 2, that's the next number, right? Multiply that into out, that's 120, yes? Get that one, and then decrement it to 1. I guess we could have stopped at 2, because like 1 doesn't do anything. Stays 120, multiply the 1 into there. But like make n 0, we for sure don't want to multiply the 0 into out now, so we better stop before it gets there, okay? So that's the idea. Stop when it gets there. Does that kind of make sense? Keep multiplying n into the out variable, decrement the n variable, and then once n is 0, we don't want to multiply 0 in anymore. That will like cancel out all the hard work we've been doing. Then we should stop the program, right? Stop it's going to be a loop, and then the out variable will hold that answer. So you see how that's going to work regardless? Like if we got a normal number like 5 or 3 or 7 or whatever, do you see how that process is going to compute the factorial? Any questions about that? Because that's going to end up being the code. That's going to be the body of the loop. And yeah, we just want to keep doing this, right? Keep multiplying n into out and decrementing n. And as long as n is a good value, to keep multiplying it, as long as it's not 0, right? So it's going to end up being a loop with this repeat until. And so now our question is like, what's true when we're done? Because it's repeat until something's true. Like keep going until this thing is now true. It's false usually. All right. The second it's true, we stop. It's like what's true about n when we stop? It's like equal to 0 maybe. That's a check that we could do. You could think about it this way as well. It's like as long as n is greater than 0, right? Greater than 0, not equal to 0. We want to keep going. kind of like that, right? So stop when it becomes equal to 0, stop when it becomes less than or equal to 0. It's like this is like we want to keep going when that's true, but in the repeat until we have to have a stopping condition, right? So repeat until, I guess let's just say n equals 0. I think that would work, all right? But that's another way to frame it as well, and that will turn into our loop. So let's do that. So all right, let's ask the user for a number. Call the scratch cat, of course. Very important to me. So yeah, when the green flag gets clicked, let's ask the user for like the number they want the factorial of, yeah? Like enter n and wait. And then we'll get into the answer variable, like whatever they wanted, right? So if I type 5, now answer will hold 5. The issue though with the answer variable is you cannot mess with it. Answer is a special variable, you cannot change it like we kind of want to change this n variable, yeah? So what we should do then is to place the answer variable into a variable that we control. So I'll go down to the orange variable section. I'll rename the default variable to n, and might as well while I'm here check it to show it. I'll make that out variable as well. So I'll just check them both so we can see them both working. So the second like we get n from the user, like it's shoved into the answer variable, then I immediately want to set n to that. Does that kind of make sense? That's what we need here. So okay, if the user gives us 5, like 5 will go into the answer variable, and then also it will go into n. You see how n is now 5 there? It's a little small. Like that. Then I can keep using n, and I can mess with n. I can change it. I can set it to some arbitrary thing. That's beautiful. Okay, so that's what we need. There's that one. And then we also noticed that out, right? Out needed to start at 1. Yeah? So we better do that too. So set out. It's always at the start of the program. Out starts at 1. Because I am I'm accumulating values into the out variable by multiplying. So that's a new word. So like accumulation in programming is like if you want to multiply a bunch of stuff into like you're accumulating a product, then you start at 1, so that, like you're not like offset by anything, and like can't do it as 0 because you'd like lose the whole thing. But when you're adding stuff in, right, when you have a variable that you keep adding into, you don't want to start at 1, right, because it's offset when you do it that way. You want to start variables at 0 when you're trying to accumulate addition results into them, right? So it's different when you multiply versus when you add, but the process is called accumulation. We're accumulating a value into the out variable. And then, yeah, so from then on, like as long as n is positive, keep going. The second n is 0, we stop. So repeat until n is equal to 0, the following, right? That's going to be our condition. Repeat until n is equal to 0, because that'll stop us, right? That'll stop us, bring us out of the loop. What do we want to do? We would like to multiply n into out and decrement n. Yes, that is our goal. So let's turn that into 2 little blocks. So multiply n into out and decrement n in that order, all right? Because that'll correspond to this drawing. So okay, multiply n into out. So that's going to be set out to be the multiplication result of like its old self by n. So that you see how that's working. It's going to do the right hand side first. Like it's going to compute this value, whatever it is, then shove it into out, replace it. That's the first step. Multiply n into out. Does that make sense? That part. Multiply n into out, and then we want to decrement n to add the next number. Like we just multiply the 5 in. Now get ready for the 4. All right. And so you can do set n to be n minus 1. You could also just say change n by -1. That's a quicker way to do it, maybe. And that should do it. So here, let me add a wait block so that we can see it working. So technically not necessary, I'll just go fast. So let me add a wait block in here so we can watch it work. Okay? So I think that's what I wanted. So when the green flag is clicked, we do all this. So I enter 5. Watch it. It's going to the 4, the 3 is going in, the 2 is about to go in, the 1's about to go in. Now n is 0, and we stopped. Do you see that? We stopped. It's beautiful. And so I guess you can see the answer here in the out variable, but maybe we'll have the scratch cat say the answer for fun. Say out for 2 seconds, just to make it nice and big. So if n is 5, multiplying the 4, and you see the very small values changing. N is 0, that'll stop the loop, and then he says the answer. Cool, and this should work for any positive values. Like if we say 4 factorial, multiplies the 4 and the 3, the 2, the 1, and the answer is correctly 24. Nice. Are there any questions about how this code corresponds to the factorial problem? At least the main version of the problem. It's pretty nice. All right, so we better also handle the issues. So yeah, like, for example, one subproblem would be like, all right, the factorial of negative numbers is not defined. We cannot have a factorial of a negative number. The factorial of 0 is defined, though. The factorial of 0 is defined in math to be 0. What happens if we try that right now? Enter n 0. It just skips the loop. N is equal to 0, and it gives back the original value and out, which is 1. So that actually works. That's pretty nice. Just for free, we got factorial of 0, even though we didn't really consider it too closely. And so that's pretty nice. Let's deal with negatives now. All right, so we don't want to get into this loop when n is negative. I hope you see. Because like if I say enter n negative 1, I'm about to type negative 1, and I hit enter, this process that we've come up with is kind of not going to work, right? Because it's going to keep on going until n is 0. It's already started negative. We're keep subtracting from n. It's never going to be 0, right? It's going to go down forever and ever. And so you see in the out variable, it's like oscillating between very large positive and large negative values. You see it going bigger and bigger and bigger. So it'll just never stop. And that's not good. So we better fix that. All right, it's going into scientific notation. The numbers are so large. So let's fix that. We better check, right, with an if. With an if, let me separate these things. So we don't want to get into this loop if n was negative, yes? So we better stop it before we get there. So if n was negative, we better deal with it. So if n was less than 0, that's how we check for negativity, right? If n was less than 0, then what do? We can yell at the user and then definitely stop the program. Yeah. So like let's say factorials of negative numbers do not exist. Exclamation point. So we've yelled at the user, and then also we don't want to just like fall through it and get into this loop now, so we better stop the program. That's down here in control. Stop all. So you see how you can't put anything below the stop block. It'll just stop the entire program. And so now this part at the start now has the check, and it won't get into the loop. So I say enter n negative 1. It'll say factorials of negative numbers don't exist. Stops the program. Does not get into the infinite loop that we did not want to get into. But all the other numbers work. It'll skip this part, right? The if will be false because like 5 is not less than 0. So go into the loop and do the right thing still. All right. So here, let me zoom out, show you the full program. Does that make sense? What we just did? So we got a subproblem, main problem. We just mapped some inputs to outputs. Questions about that? Make enough sense? All right. Do yell at me if you notice any issues that you want to talk about. But I think that's my first example that I will save. All right, let's try another. So, okay, let's have a problem where instead of multiplying, we'll add. So let's sum up all the numbers from n1 to n2, where those are two things that the user is giving me. So, for example, if the user types 2 and 7, they wanted the sum of all the numbers from 2 to 7. Okay, they wanted us to do this. 2 plus 3 plus 4 plus 5 plus 7. Not plus 7 yet. Plus 6 plus 7. That's kind of a cool thing, right? Something useful to have. Like, what's the sum of all the numbers in this range from here to here? Okay, does that kind of make sense? That's the problem. And now, how do we solve it? So, okay, what are the inputs? What are the outputs? Then, like, what's the algorithm that we have to come up with to take the inputs to the outputs? So, okay, we're getting two things from the user each time. So it's going to be two variables. We'll call them n1 and n2. They're both numbers. We're not getting words or strings from the user. So that's the first thing. And then the output is the sum of a bunch of numbers between n1 and n2 inclusive, and that's also a number. So we're computing a number based on two input numbers this time. All right. And so now the goal is like, how do we do it? How do we do it? So we got a sum from n1 to n2. We'll have to figure this out. All right. So there's the main problem of like figuring out the sum, but you also think about like how could the user do this wrong, right? So what if the user gave us the numbers 7 and 2 in that order? They wanted the sum from 7 to 2. Would you just go backwards? Would it still work? Would you want it to still work? Or maybe the point of your program was to add up all the numbers from the first one to the second one increasing, right? There are no numbers increasing from 7 to 2, are there? So do we yell at the user? It's up to you. I have to figure that out. So see how that's a problem you have to consider, because it might mess up the main way that we're doing things if we assume that the first number is smaller. See that? So let's assume that that is true, and let's tackle the main problem, and we'll come back to the sub problem. All right. So like actually computing the sum from n1 to n2, like the user gave me this, like n1 was 2, n2 was 7. Okay. So how do we do that? So we want to add a bunch of numbers up, right? Starting at 2 all the way to 7. So we better have a place to store the sum, just like we were doing here. Let's have an out variable. Let's do that again. Though because we are adding things, we can't like start it at 1, right? Because it will be like the answer will be off by 1 now. If we're adding a bunch of stuff, we accumulate values starting at 0. Yes? That's what's going to happen. And then we're going to keep on adding numbers 2, 3, 4, 5, 6, and 7 into out. I have the first number, don't I, in a variable? That's convenient. So it looks like n1 I can use right now, right? n1 is the first number I want to start adding in. So let's work with n1. I think that'll be useful. That will be fruitful. So let's add n1 into the out variable, because that'll make it 2, right? And then how do I get the 3 for the next number? I can keep using n1. Now I can increment it. Does that make sense? So I'm getting the next number that way. So all right, now n1 holds 3. I can add that into out and increment. Now it's 5, right? Now make it 4. Add that into out, increment. That's 9. Make it 5. Add that in to out. That's what, 14. Increment n1. 6. Add that into out. That's 20, right? Increment n1 to 7. Add that into out. Now it's 27. So 7 was the last number, right, that I care about adding in. Like if I increment it one more time, now it's 8. 8's bigger than 7, right? That was not a number that I cared about. But I know the edge of this range because it's sitting in n2. You see that? So I can use n2. I'll keep changing n1 to get the next number I want to add in. But n2 will tell me when I'm done. Do you see that? That'll be the secret. That'll be the trick. So let's see. Just like if n1 ever becomes bigger than n2, I am done adding numbers. That's our stopping condition. That's our repeat until. Yes? That's the idea. So like repeat until we do all this, right? Repeat until n1 becomes bigger than n2, because then it means n1 holds a value I don't care about anymore. See that? That's the trick. So yeah, just like keep on doing that. Oh, sorry, the first one is not repeated. That's initialization. This is repeated. Okay, add n1 into out while it's less than or equal to n2, and increment n1. So like what makes the stopping condition? Like when this becomes not true. It's like when n1 is bigger than n2, like the 8 versus the 7. All right. So that'll be the main algorithm. Are there any questions about that? Does that make enough sense for now? Let's do it. So, yeah, when the green flag gets clicked, I need 2 numbers from the user, so I better just like get them ready. So variable n1, variable n2, variable out. Those all need to exist, right? And then we're getting 2 numbers from the user. We still always have to use the ask block for that number. And so let's just keep doing that. So all right, let's have the user enter n1. Have the user enter n2 eventually. Because, right, we have to do something in between. Because the ask block only affects this answer variable, and so like the first time they enter, it's the value that's supposed to go in n1. So like after they get the value, I better immediately put whatever's in answer into n1. Like set n1 to be whatever answer is, and then do the same thing for the next one. Like enter n2, then I better set n2 to whatever answer was. Does that make sense? Because like answer holds whatever the user typed. I want to shove those into the variables I'm using here. Because I can mess with those. I can mess with my own orange variables. Answer I cannot like decrement or anything, sadly. It's like that's perfect. I needed 2 of them anyway, so like I better have like in between got the values. So this will set those properly. It's like 2 and 7. Like there they are set properly. And now I want to use them. Alright? So let's figure this out. Dun, dun, dun. So, okay. I would like to repeat a process until n1 is bigger than n2. Yeah? Oh, then also, sorry, out needs to start at 0. Out should always start at 0, excuse me. We better initialize all of our variables. That's the last piece. Starts at 0, and then I can repeat. All right, so I want to do a repeated process until n1 is bigger than n2. That's what we decided. All right, and so let's do that first until n1 is bigger than n2. n1 bigger than n2. And then what is the process that I am repeating? I am adding n1's value into out. Whatever its current value is, it goes into out. Then I increment n1. So, okay, that means set out to be the sum of itself plus n1. See how that's the first one? That's add n1 into out. It's taking the current value, adding it into out. It's computing that sum and putting that sum into out. It's kind of, you read it right to left. All right, so that's the first part, and then we increment n1 after that. So that will just be a change n1 by 1. So that's the process. And again, I'll add a wait block just so that we can watch it work. But that should do it. So we're getting n1, n2 starting out at 0. That's the relevant code. And let's see if it works. 2, 7, looking out, getting bigger. 4, adding the 4 in, the 5 in, the 6 in, the 7 in. We got 27 in the out variable. Woo. Does that make sense? No questions about that? It's doing the right thing for now. I guess we should also have like the scratch cat shout out to the world the answer, so it's not nice and small. It's like say out for 2 seconds or whatever. So again, 2, 7. Add in the 4, add in the 5, add in the 6 into out, the 7 into out. Now it's 8, so it's big. So we stop the loop, but we output the answer. Nice. So that's like the main problem. Okay. Any questions about the main problem? So working enough for us. So there's that. And then we have to handle the subproblem. Like, okay, what are all the ways that the user could mess up? You got to think about these things. So like, what if n1 is bigger than n2? The user's like, add all the numbers from 7 to 2 in increasing order. And there are no numbers increasing from 7 to 2, right? It's backwards. So maybe you're like, all right, if there are no numbers, I'm adding up a bunch of nothing, so maybe the answer is 0. Maybe the answer should be 0. The user gives you things backwards because you're meant to get things in increasing order. It just so happens that if n1 is bigger than n2, immediately you'll skip out the loop entirely, and out is already set to 0. So we actually got that answer for free based on the code that we have. If that is the answer you wanted, we are now done. Does that make sense? That's kind of cool. That's useful. Some things just fall out from the sky for us for free. That's quite nice. But like that's a problem you have to figure out yourself. All right. So if we get bad values, what do we do? Maybe we should be yelling at the user. If you want to yell at the user, you better use an if. Okay. But maybe 0 is the right answer here. I'm not sure. It's up to you. So I think that's what I wanted to say about this program. Any questions about this one? Let's see if I can show it to you entirely. Good enough. Can I do with that? All right, so if we are confident, I'm going to give you this code, and then I'm going to have you try something. So here's this code, and then here is your task. All right, so I'll put this right here. I'd like you to make a program that kind of works like this. You don't have to add a cool backdrop like I did in my example here, but here's like how I want you to have your program work. All right, I'd like you to have a program that asks the user for a number that's bigger than 0, just assume that they're giving that to you, and then have the scratch cat count out from 1 up to that number that the user gave you. All right. So like for example, if you type 10, the scratch cat will start counting from 1 to 10. That's my example recording here. Watch it work again. Count up to 10. It goes starts at 1, gets his way up to 10, but he outputs each number each time. Does the problem make sense? Your task makes sense? So that's what I want you to do. Here's my sample code from the last program that we just wrote together. Let me make sure that I save that as well before I get rid of it. And then I'd like you to think about, right, as you're breaking it down, like figuring out how to do it, what is the input? What is the output of this problem, right? What is the main problem? And then are there any sub-problems that you'll have to tackle? Like, all right, what if you don't trust the user? Like, what if they give you a negative number? Will it stop things? Will it mess up the way that your program has worked so far? You have to think about that. So I think that is what I wanted to tell you. Yeah, I'll give you a few minutes to try to think about it yourself, and then I'll give you a hint after that and keep letting you work. All right, so go off, ask me questions if you have any, but give this a try. And then I'll stop attendance as well, so make sure to do attendance if you have not already. I'll do that after we're done with this. What will you need? What is going to be the algorithm? What are you getting from the answer? What are you doing with it? It's not just one answer, right? It's a bunch of answers. A bunch of things all at once. All right, here's my hint. I'll draw it as you work. I think, well, you're going to need a number. You call it something, right? The user gives you a number n, like 10. They want you to count up to 10. So I think you're going to need another variable, right? Call it like counter or something. The very first number you want to output is always 1. So I think that's what should go in there, right? And then, do you see how you could like print whatever's in there, make it bigger? Print whatever's in there, make it bigger. Print whatever's in there, make it bigger. Print whatever's in there, make it bigger. Until you hit 10. Right? And then you have the end. You know when you're done, right? Because it's over here. You have to come up with a condition. Because you're going to keep looping that process, right? Print whatever's in that variable, make it bigger. Eventually it will become 11, and like that versus that should tell you to stop. Does that kind of make sense? So if you did not already understand that, now you do. Keep trying. Give you a few more minutes. All right, that is my timer. Yeah, are there any questions about this as we were trying it? Does it make enough sense? Let me show it to you. I promise. I'll stop that in a second. Did I save this? Yes. So here's my thought. Can I just reuse these old things? I can delete some variables. I'll call this one counter. I'll do exactly what I wrote. N, there's just an N and a counter variable. It's like when the green flag gets clicked, I'll just do this very quickly. Ask the user, like, what do you want me to count up to? I'll just say enter N, just to make it quick. And then I'll set N to be whatever that is, because that's my stopping condition. Then I want to start counter at the first thing I want to print, which is always 1. Yeah. So, all right, set counter to 1, and then until counter is bigger than N, right? Just keep on doing show counter and make it bigger until counter is bigger than N. That means it's a value I still care about printing. Then I'll print it out. Say counter. First it's the 1, then it's the 2, then the 3. Right, it's going to go all the way up to 11, but we're not going to show 11 because then it will be bigger. That will stop our loop. All right, and then make it bigger. Make counter the next number. So it was 1, print the 1, and then show now it's time for 2. Okay, that's the goal. And we will need a wait block in between because watch, enter N like 10. Whee. Or no, sorry, we don't. Sorry, excuse me, because it's saying for 2 seconds. If I said just the say block, it would have messed that up. It would have gone too fast. But yeah, because he's saying it for 2 seconds, he's going to stay there for a second. And that's probably too slow. Let's change it to 1. Cool. And so yeah, for a split second, it gets to be 11, and that's what stops us. All right. So I think that's my answer. Does that make sense to us? Is that what we got? Questions about that? All right. So I'll save that if you want to see it. But that's my answer. Yeah, are we good? I have completely different topics now. Are you ready for them? We're very alive today, I can tell. All right. So, what I want to do next is talk about a feature of Scratch that I have not yet shown to you. It's called custom blocks. So, I think I'd rather skip this one. I'll let you try it yourself. Make a sum from 1 to n block and give it like stuff. But I think I'd like to make this block. A block that's just like, remember in Pong, there was like if on edge bounce, and then we did some weird stuff to like check if the ball is touching the paddle, and if so, bounce off. Like a big long if. So let's make a block that does that. We can make our own blocks. Right, that's the goal. So that's pretty nice. We can make our own blocks. It's right here in this My Blocks section, the last place we've never been before. You click Make a Block, and like you can give meaning to your own blocks. That's the goal. All right, that's what we want. And yeah, just the goal of doing that is that lets you like make it easier to represent what you want to do. All right, and then you can give meaning to this block in some other place. It's all about breaking down problems, right? Well, this programming lecture, right? Break down problems into smaller pieces and smaller pieces. and we can have that mean blocks today. So why not break it down into smaller blocks? So that will make our lives easier, I think. So let's go back to the Pong code. I forget which lecture it was in. Let me go find it. Lecture 9, apparently. I assume it was the last thing we did in lecture 9. So let me load that file. Load from this. We are here. Lecture 9. The very last one was this one. Yep. Cool, that was it. There's my Pong program. So remember, we got ball stuff, paddle stuff, line stuff, checking if we lost the game, then our custom you lose sprite. That starts out hidden. So here, let's go back to here because it was right here, right? This part. This code right here was checking if we touch the ball touch the paddle, right? Because it's from the ball's perspective. If the ball is touching the paddle, then we bounce off by turning. Do you remember that part? That's what it does. So it's just always checking, like, am I on the edge? If so, bounce. And then also, if I'm touching the paddle, then also bounce. Does that make sense? Is it coming back to us? So what I want to do is have another block just like the if on edge bounce, like if touching paddle bounce. That would make it cleaner, easier to read, easier to understand. Let's do that. All right? That is our goal. So the way you do that is you say you click make a block, and then you could add input. We don't need input. Like I encourage you to try it because you can make a sum from one to n block if you wanted to. Like print, count up to something block. But we just need a block that has a name. So we'll say if touching paddle bounce. And that will be my block. All right? And what happens is once we say that, it gives us this little define thing. I'll just drag over here for a second. And then it gives us our block. Then it gives us this block that we've made, and that's pretty nice. Because then I can put it wherever I want to use it, and then I can get rid of this. But it's really not getting rid of the code that really was doing the bouncing. Oh gosh, I did not mean to do that. It's not getting rid of it, it's moving it. All right. So first of all, does it make sense how this code is so much easier to read now? It's like, all right, what is the ball doing? It's moving in its little direction. It's bouncing off an edge if it never hits one. And if it hits the paddle, it should also bounce off. Does that make sense? That's what we want. That is clean. That's very easy to read. And now the last piece of the puzzle is to give meaning to this block. Because like you can't just type words and expect something to happen. You have to give meaning to the block, and that's in this define section. Right? So this comes with define. It's like an event because it starts a computation. So what's going to happen is whenever this block hits in your code, it will jump over to the define block and run whatever's in there. That's the meaning of the block. Does that make sense? That's what we're doing. So we've just given meaning to the block. So whenever this runs, it'll go here and do this, which was the old stuff. It's just in a spot that's like easier to like pick out and understand what it's doing. All right. So like this code is easier to think about. This is a smaller problem. Just like what do I do if it's touching the paddle? Like here, do this. Does that kind of make sense? Those two pieces together. Define a new block, and then we have to give meaning to it. Here's what we want, just the same stuff. And so watch it work. I'll have to zoom out a little bit so you can see them both at the same time. But that should do it. I got a bad game. There we go. It ran. It just keeps on checking. Let's have a better, more. Oh, that's even worse. There we go. So it's running every time the ball moves. It's checking in the same stuff by running our block now, though. It's running our block, which is much easier to think about. All right. So, are there any questions about that? It's a new block. We just give meaning to it. What do we want What do we want to have happen when it runs? I think that's pretty cool. So I like that a lot. And then finally, let me fix the problem that I promised I'd show you how to fix eventually. So like what we've been doing is when the ball comes in and hits the paddle, it bounces off in that same opposite direction, which is not how Pong works. That was lazy. That was just to make it easy on ourselves because we were learning a bunch of new stuff at once. The way that the ball should have bounced off, right? If it was coming in this way, it better have bounced off. Oh, gosh, PowerPoint, not right now. It should have bounced off that way. Yeah, that's the right way to do it. So we need to do that. And then likewise, if it was coming from the bottom, like coming that way, it should have bounced off, not back that way in 180. It should have bounced off that way. That's how physics works, right? So let's program that now. So instead of do a 180, let's figure out what really needs to happen. So, okay, we've got our paddle. How do we, I don't know, man. Let's move it. We got our ball. Let's think about this. So if the ball is coming in, right? If the ball is coming in at, let's say, I don't know. Let's do it this way. That's probably fine. If it's coming in at negative 60, that's its direction. That's whatever that is right now. It's set to negative 60 apparently. We want to bounce off that way, right? Go to that direction, right? That's what we want. What angle is that now? If it was negative 60 coming in, we want to bounce off. It looks like positive 60. Okay. Likewise, if it was coming in this way, negative 130, we want it to bounce off, right? That way, which is, positive 130. The Scratch people made this easy for us, didn't they? Just take whatever your initial direction was. If it was negative 60, negate it. Multiply it by negative 1. Make it positive 60. That's going to be the right thing. That was very nice of them. That's not how normal angles work. They did that for us. So if it was coming in negative 155, it should bounce off at positive 155. That's exactly what we want. Does that make sense? Just like by messing with the slider, we discovered that. And so that's going to be the right answer. So instead of turning 180, it's not that at all. It's set the direction. Point in the direction that is the negative version of your current direction. That's the answer, right? So I'm going to need this point in direction block. And then we can always get our current direction with a direction variable, whatever it is, and we can just take that and multiply it by negative 1. That's the right answer. Point in direction, whatever my current direction is, times negative 1. That will flip the sign of it, and that's what we noticed we needed to do. So now whenever we check that, touching paddle bounce. Oh, look at that. That is so satisfying. It's exactly the right way it should be doing it. Boop. And so, yeah, we just noticed that. And that is nice. That is beautiful. Are there any questions about that? How we changed it? Because that's how it should be. Everything is right in the world now. And then we can still lose the game, of course. But yeah, that's a new block. You just you put it wherever you need it. The whole point is to make your life easier and potentially reuse it. You just give meaning to it as well. Whenever it runs, it's going to jump to here, this define part, and run whatever you gave as the definition of your block. Okay? So I think that's that example. Questions about that before I do another one? All right, so I'll give you all this code, of course. And yeah, for the last piece of the puzzle, I want to do one more example. All right. Let's make a state machine, because I talked about those. Let me show you how to actually program one, all right? Let's make a state machine, and let's have it check if a number that the user gives us digit by digit is divisible by 5. So divisible just means multiple of 5, right? So let's pretend that the user's given us a number, a digit at a time, and we have to figure out, is the number so far a divisible by 5 or not? So first of all, how do you know that the number 51 is not a multiple of 5? How can you notice that immediately? How do we know that? Yeah. Good, yeah, because we're looking at this number. It's if it's a 1, that's not useful. But if it was a 5, then it would be multiple of 5, right? That's how we know to look for that. If it was a 0 as well. Just is the last digit a 5 or a 0? That tells you if the whole number is a multiple of 5, right? That's the trick for at least multiples of 5. So we're going to make a state machine to do that. If the user gives us 5, yes, that one's divisible. The user gives us 18, say no, that's not divisible. But the goal is we're going to have the user type a number digit by digit. So they're going to type 5 first to build up just the number 5 so far. And then they'll type the 1 next, and then they've built up 51 based on that. This kind of makes sense. They're giving us the number a digit at a time. And based on what they've given us so far, we'll say if it's divisible or not. So if it's 51, it's not. But if they type the next digit, 0, now suddenly it is a multiple of 5, right? 510. If they type another digit, now suddenly it's not a multiple of 5 anymore. Just always like that, okay? It's we need to notice that. If they type another digit, though, if it's a 0 or a 5, then the number that they built up so far is suddenly a multiple of 5. That's how we're doing it. We want to, at the very end, notice that, yes, that one is, but like the one that came before 5,108 was not a multiple of 5. So if the user gives us a digit at a time, what we can do is make a state machine that just like plugs into that digit, whatever they gave us. All right. So there's going to be 2 states to our state machine that will check for if our number so far is divisible by 5 or not. So it's going to be, the first state is like it's not divisible by 5. And the other state is going to be divisible by 5. If the user has not given us a number yet, it is for sure not divisible by 5 yet. Okay, so that's our starting state. And then, just like as the user gives us numbers, the second they type a number that is like the 5, they built up the number 5 or something, they type a 0 or 5 as the last digit, suddenly the number is divisible by 5, right? As long as the last digit, the number that they just typed, is a 0 or 5, we're always in the divisible by 5 state. Yes? That's the secret. But if the user ever gives us a number that's not, like they type the 5, we're over here, they type the 1 now, we're not divisible by 5 anymore. 51 is not divisible by 5. So they give us not 0 or 5, then we're back over here. All right, and as long as they keep doing that. If they give us 511, for example, if we were already over here, we stay over here. We keep getting not 0 or 5. So that's a state machine that will just, like, based on the digits that the user gives us one by one of a number, tell us whether or not currently the number is divisible by 5 or not. Does that make sense? That's state machines all over again. Now the question is how to implement this. So it's kind of cool. I would like to show it to you. The secret is you're just going to make a variable to keep track of which state you're in. That's the easiest way to implement a state machine. Just like make a variable called state or something. And then we're just going to make numbers out of what state we're in. Let's say we'll encode the fact that we're in this state as like a 0 maybe. And then we'll encode the fact that we're in this state as like a 1. That'll do it. And so like the state, because like this is the first state, the starting state, because when you haven't typed a number yet, it's not divisible by anything. The starting state is 0, but it may eventually become 1. We're just going to mess with that variable and know which state we're in. That's going to be the first part. And then based on what state you're in, you're getting some input from the user. You have to transition, right? Those are those words that we talked about before. And it's just going to be a bunch of ifs, like based on what state we're in and the value that we just got as input, like move in the state machine. Okay? That's going to be it. That's going to do it. So here, let me show that to you. Let's make that happen. Did I just save this? Yes, I think I did. One more new file. So what I'd like is the user to give us numbers a digit at a time. Okay? So I think the best way to do it, well, first of all, we're going to need a state variable. Like, what state are we in right now? Rename it to state. So we'll have a state variable. And at the very start of the program, we're going to be in the not divisible by 5 state. So we're going to encode 0 as that. So the state should start at 0. That's my goal. That means we're not divisible by 5. 0 equals not divisible by 5. 1 equals divisible by 5. So it starts in a not divisible by 5 state because we have not gotten a number yet. And then we're just going to keep asking the user to give us the next digit. All right? So that will be with an ask block, like, all right, enter the next digit, enter the next digit, and wait. I accidentally typed that. All right, cool. So enter the next digit and wait, and then we get the next digit in the answer variable. So we just want to loop that, right, forever, until the end of time. Because the user, we don't know when they're done. It's like, enter the next digit, give it to us, and then based on the next digit, right, based on answer, we have to, in our current state, we have to move our state machine. So like based on the value of answer and the current state we're in, we have to run the state machine on that input that we came up with, okay? And so it's just a big long if then else. So like if we're in this state, do something based on our input, or otherwise if we were in this state, do something based on our input. So either the state is 0 or 1, there's an if then, right? So if our current state was equal to 0, or if it was equal to 1, we're doing one thing or another thing, okay? That's here. So if the state was equal to 0, that means we were in the not divisible by 5 state. Let me move all these up here, make them smaller. So this is the not divisible by 5 state. So if we're in the not divisible by 5 state, we just got a digit, right? It's an answer. What do we do with it? Well, it depends. Depends on that digit. So if the digit was a 0 or a 5, we better transition to this state, which means change the state variable to 1, yes? Otherwise, we stay in our same state if we got a not 0 or 5, okay? That's going to turn into another if then else, okay? It's like, all right, if our state is 0, if we're in this state, based on what we just saw, either we saw a 0 or 5 or not 0 or 5, we better check for that now, because we're doing one thing or another. So again, it's another if else. It's going to look disgusting, I know, but that's what we got to do. So all right, based on now what kind of digit we just saw. So either if it was a 0 or a 5, we got to transition. So let's check for 0 or 5. Let's have something that's true if it's 0 or 5. So if answer is equal to 0, oops, that's going to get really disgusting. So if answer is equal to 0 or answer is equal to 5, any of those are true, then we saw a number that makes us a multiple of 5. The last digit was a 0 or 5, we are good. So that's our big, long, chunky condition. Disgusting. But that's what we need. It's like if the number that we saw was a 0 or a 5, if answer is equal to 0 or if answer is equal to 5, that's our next digit, then we transition to this state. Yes? Divisible by 5 state, which means set the state variable to 1 because that's what we're using to track that. Okay? It's getting a little complicated, but that's the trick. So, okay, set state to 1. All right, that's how we encode that, right? Now, that means we've transitioned, yes? Transition to the divisible by 5 state. Beautiful. All right, otherwise, okay, let's think about what just happened. So we're in this state 0, right? We're only here if we're in state 0. That's this one, not divisible by 5. We did not see a 0 or a 5, right? We're hitting the else. We did not see a 0 or 5, then we just remain in our current state. So you could have just had an if, I guess, because you could leave the else empty, or you just like, to make it very clear, you'll set state to 0 or something. That would work, okay? That's how you know whether or not your number is divisible by 5. Then we do the whole thing all over again for this one. So, all right, if we weren't in state equal to 0, we were in this else then, that means we're in state equal to 1. That's our only other option, our divisible by 5 state. And so again, it's going to be another if else based on whether we saw a 0 or 5. Okay? Based on whether we saw a 0 or 5. So if we did, we stay in this state. We stay in this state. It's still set to 1. So you could clean this up a bit because it's going to be the same across each one. But like this is the long way to do it. Like, all right, otherwise, if we're in this state and we saw a 0 or a 5, then remain in this state. So keep state set to 1. That's what it should be. And though if we did not, right, if we did not see a 0 or 5, we're in this else, that means we need to transition over to here, change our state to 0, right? So like this is, you could have kept this one blank, I guess, because we're already in state 1, but like this one definitely needs to be there. Does that make a little bit of sense? It's a little complicated, but like that's what needs to happen. And now this variable just keeps changing based on what we got. Forever until the end of time, we're asking the user for the next digit and messing with our state variable based on it. So let me type 51,080 to show you it working. So the first digit is 5. That took us to state 1. It is our number so far. 5 is divisible by 5. Okay? And if I type 1 to mean 51, the state moves back to 0. So 51 is not divisible by 5. 510, though, if I type a 0 next, now it's built up 510. State got it back to 1. Now we are divisible by 5. Beautiful. If I type an 8, 5108, 5108 is not divisible by 5, so state goes back to 0. And then one last time, if we type another 0, 51,080, it goes back to 1. Glorious. All right. So this is a little complicated. You could clean this up. I highly encourage you to try, because like the if then else is like the same across both states. Doesn't really matter which state you're in. But like that's like the step-by-step way. You can clean it up later of programming a state machine. All right. I think I promised you that, so you needed to see that. That's how you do it. Just a bunch of ifs, if then else's, and it's like use a variable to keep track of what state you're in. Okay. Are there any questions about that? It's a fun little program. A little complicated, but it's good to study. All right, I have saved it. Yes. All right. So here, if we are happy, I have one last question for you to try. All right. You do not have to write this down on the written ice page. Don't feel free to stay like as a group. You're going to get together with the people sitting next to you. And I would like you to help each other create not a divisible by 5 state machine like this one, but a divisible by 2 state machine. How can you make, very similar to this one, a state machine that gets numbers digit by digit, like 1, 2, 3, 4, and then based on how many digits you've seen so far, you've built up a number. Like, how do you take those digits and know just immediately, like, all right, if you saw 18, like, yeah, that's a multiple of 2. If you saw 510, yeah, for sure, that's a multiple of 2. If you saw, like, 81, no, it's not. 47, no, it's not. You can kind of play a similar game, can't you? Do you see it? It's very easy to see if a number is divisible by 2 in a similar way to the way that you saw if it was divisible by 5. All right? So please get together for a couple minutes, discuss how you might change this state machine to be one that checks for a multiple of 2 rather than 5. How would you do it? What would you change? Draw it out if you need to. I don't care if you don't talk to me, but you guys. Get together. Did we come up with the answer? Either that or we're confused. Tell me which one. What would we change? More or less, but it's more than just 2, right? Because like the number 18, there's an 8 there, and it's suddenly divisible by 2 still, right? It's more than just like 0 and 2, isn't it? What are the numbers? What are the digits that tell you if a number is divisible by 2? Have we forgotten them? Yeah. Yeah, but it's an even number, right? If the number is even, it's divisible by 2. The last digit was even. Does that make sense? We remember this, right? I hope that we're just shy today. Otherwise, this is a problem for your future math classes. It's like, if we saw that the number ended in 0, 2, 4, 6, or 8, it is for sure divisible by 2. Yes? Does this make sense to us? We know this. I hope. Okay. And then, yeah, that's pretty much it. Like, if you saw that, then, like, that's what you're going to change. Like, all right, if you saw a not divisible by 2 number, that means it ended in an odd digit, like 1, 3, 5, 7, and 9. And then you, like, change the rest in the same kind of way. But, like, that'll take you between, like, all right, your number is divisible by 2, or it's not. Either you just saw your last digit was even, or it was odd. Do we get it? Are there any questions about that? I wanted you to ask the questions if you're not getting it. It's very important. And then, yeah, notice how like you would start at 1. Like, all right, now it's not divisible still. It would suddenly become divisible because you built up 12. And then it would suddenly go back to not divisible, back to divisible. That's how it would work. Okay? So I think that is what I wanted to show you for that example. Yeah, any last questions about anything we talked about today before I talk about your next programming assignment? That's the last thing I want to do. All right, we do have a midterm coming up, so you guys should practice asking questions because I feel like there was something we didn't understand, but we didn't ask a question about it. So I'm just going to assume we're good and test you on it. So, all right, here we go. Let me give you your next programming assignment. This one will be due week 9, so after the test. It would be evil to give you something due before the test. So just keep track of that due date. And here now is the last Scratch programming assignment. This is exciting for me. So this was the last lecture on Scratch. This is your last Scratch programming assignment. And I just want you to go crazy, do whatever you want. So yeah, if you're doing the Scratch assignments, do whatever you would like. I would like you to implement whatever you would like, make a game or something, whatever's fun for you. Some kind of program, as long as you do the following. All right, so you can make whatever you would like, just go crazy, some wild scenario, and I want the following though. So you must have at least 3 key press events. So like go left, go right, move up, or something, like walk around, for example. You do like a top-down game or something, but like have 3 key press events. When 3 separate keys are pressed, something happens. You must use at least 2 conditional blocks, like if then else, or just if then with no else. So use at least 2 conditional blocks, right? It's like checking one thing or another. It's like to practice your condition writing. Like if something's true, do one thing. If it's false, either do nothing or do something else. So at least 2 of those, and then at least 2 looping blocks, right? Ones that repeat stuff. Forever block, repeat until, stuff like that, okay? So those are the hard requirements. You can make whatever you want around those requirements, okay? The only thing you can't do is copy something we did in class. So don't make Pong again. That would be too easy. But you can build off my examples, like maybe make 2-person Pong or something like that. That's the thing. That would totally be okay. So yeah, just use your judgment there. But I think that's what I wanted to tell you. Does that make sense? Like make whatever you would like, as long as it's new and it has those features inside of it. And yeah, you'll make a video to talk about what you did and explain your code to me. This should be a bit of a longer video because like you're doing something brand new, right? Something I haven't really told you to do. So you better explain it and tell me like what you came up with and talk about it a little bit longer than usual because there isn't like a prompt for you anymore. It's just like up in the air. So I need an explanation as well. But I think that's it, just as usual. You're making the program with those requirements and give me a video about it. We're good with that one? All right. For those of you doing the racket assignments, this will be your assignments of these chapters of the book, and I would like these exercises, please. So as usual, just like everybody else, give me a video, tell me about what's going on and how you solve the stuff, and I think that is all that I wanted to say. Are there any questions about that? All right. So yeah, this will be due in a couple weeks because we got that midterm coming up, so you got some time. But start thinking about your fun example programs for those of you doing the Scratch one. All right, I think that is officially all that I have for us today. The rest of the time is yours to ask me lots of questions.